Good day, everyone. I am Joshua Gililok, Stream 2 students from Misamis Oriental Institute of Science and Technology. For today's discussion, we will be tackling about the Forensic Photography Chapter 2, about the photographic rays, its nature and characteristics. Do you have any idea about what is the use of photographic rays? We should remember that it is essential in our chosen field, as we can use it as a tool. Since it enables us to record the visible and, in many cases, the invisible evidence of a crime, special technique employing infrared, ultraviolet, and X-ray radiation enable us to record evidence which is not visible. The photographic evidence can be stored indefinitely and retrieved when needed. Here, what can you see in these slides are the different forms of light. We have here the natural light and the artificial light. But when we see light, what ideas that comes up in your mind? Or how do we define lights? Light is defined as the electromagnetic radiation with wavelengths between 380 and 750 nanometer, which is visible to the human eye. Light is an electromagnetic energy with a speed of 186 miles per second. Its wave travel is said to be characterized in certain extent based on velocity, wavelength, and frequency of the number of variation of the wave per second. And light is one of number of known form of radiation electromagnetic energy which travel in wave motion. Light can be largely be classified into visible and invisible light. Visible light is the type of light that produces different sensations who reach the human eye. Invisible light in which their wavelengths are either too short or too long. To excite the retina of human eye, example, the X-rays, ultraviolet, and infrared lights. Actually, there are other theories that explain the behavior of light. First, the wave theory by Huygens, the most acceptable theory. It is the theory that was transcribed from the motion of the water, that if we observe a piece or a flag floating in the ocean and with the force of the air would naturally will make the log move up and down. Are other theories that explain the behavior of light. Second, corpuscular theory by Newton. This later opposed the Weiss theory, stating that light has its effect by the motion of very small particles such as electrons. Third, modified theory by Maxwell and Hertz. Based on electromagnetic, all these theories are still considered to be a little lacking, that law enforcement need not to be refocused on this but rather go along with the accepted conclusion that light is a form of energy, which is electromagnetic in form, and the quantum theory Albert Einstein in 1905, Albert Einstein postulated that light might actually have some particle characteristic regardless the overwhelming evidence for a wave-like nature. In developing his quantum theory, Einstein suggests mathematically that electrons attached to atoms and to atoms in metal can be absorbed a specific quantity of light. Wavelength. Wavelength can be defined as the distance between two successive crests or through of a wave. It is measured in the direction of the wave. Wavelength is the distance from one crest to another, or from one through to another. Crest is the highest point of the wave, whereas the through is the lowest. Since wavelength is distance, it is measured in units of angstrom such as meters, centimeters, milliliters, nanometers, and etc. Wavelength of light varies with colors. It is different for every color. Red color has the longest wavelength while violet has the least. The wavelength of UV radiation is shorter than violet light. Similarly, the wavelength of infrared radiation is longer than the wavelength of red light. Wavelength is inversely proportional to frequency. This means the longer the wavelength, lower the frequency. In the same manner, shorter the wavelength, higher will be the frequency. The different energies in electromagnetic spectrum are the following: cosmic rays, gamma rays, X-rays, ultraviolet rays, visible, infrared rays, heat rays, Hertzian waves, and the alternating current oscillation. The electromagnetic spectrum can be expressed in terms of energy, wavelength, or frequency. Each way of thinking about the EM spectrum is related to the others in a precise mathematical way. Scientists represent wavelength and frequency by the Greek letters lambda and the nu. Using those symbols, the relationship between energy, wavelength, frequency can be written as wavelength equals to the speed of light divided by the frequency. When we say cosmic rays, those are high energy proton and atomic nuclei that move through space at nearly the speed of light. They originate from the sun, from outside of the solar system and our galaxy, and from distant galaxy. Upon impact with Earth's atmosphere, cosmic rays produce shower of secondary particles, some of which reach the surface, although the bulk is intercepted by the magnetosphere or the heliosphere. Gamma rays come in just after X-rays, but with wavelength less than 10 picometers. and frequencies greater than 1019 Hz, discovered in 1990 by Paul Villard, gamma rays impart the highest photon energy. This is especially so considering their wavelength does not have a defined lower limit. Gamma rays are commonly used in the irradiation of seeds of food for sterilization. Unlike visible light, X-rays have higher electromagnetic energy that can penetrate most objects, including flesh. Like UV sulfur range, X-rays are also ionizing. X-rays interact with matter through the Compton effect, and its frequencies are in the ranges of 3 petahertz to 30 exahertz. Then fall into two primary forms, hard and soft X-rays. Soft X-rays have longer wavelength compared to hard X-rays. Ultraviolet rays wavelength is longer than X-rays but shorter than the violet end of visible light. Ultraviolet light stands out the longest wavelength radiation that can ionize atoms through its energetic photons, unlike visible lights. This separates electrons from atoms, thus leading to chemical reaction. Visible light is the portion of the EM spectrum that is the most sensitive to human eyes, sometimes referred to as near-infrared light. Visible light's absorption of emission are made possible by electrons in atoms and molecules that hop from one higher energy level to another. Infrared, this small portion of the electromagnetic spectrum, is an extension of the long wavelength to the microwave range. Unlike light, it is usually invisible to human eyes but can be felt in the form of warm sensation to the skin. All objects found in the universe emit infrared, but the most obvious source are the fire and the sun. The energies that are capable of being recorded on sensitized material are the X-rays, ultraviolet rays, visible lights, and infrared rays. They are sometimes referred to as the four photographic rays of modern photography. The wavelength of X-rays is from 0.1 to 30 nanometers. Ultraviolet rays from 30 to 400 nanometers. Visible light from 400 to 700 nanometers, and infrared rays 700 to 1000 plus nanometers. Actually, the wavelength of infrared rays extend beyond 2000 nanometers, but the longest wavelength that the present sensitized materials could recorded is only up to this limit. The Webster Dictionary defined light as a radiant electromagnetic that can be seen by the naked eye. The scientific definition of light is the aspect of radiation energy of which a human observer is aware through the visual sensation, which arise from the stimulation of retina of the eye. Light rays with a wavelength of 400 to 700 nanometer is referred to as visible light because it is only within this wavelength that the human eye is capable of perceiving. Those with the shorter or longer wavelength are commonly referred as invisible radiation. By definition, all lights are visible. For this reason, the word visible is superfluous in that common expression visible light. What the eye cannot see are referred to as relations. Light energy has several effects on an object. It is either reflected, observed, transmitted, or converted. The varying combination of these reflectance and absorption are what gives us the wide variety of colors, which we are able to perceive at times. Other lights are neither reflected or absorbed, but it's transmitted through the object. This transmitted light passing through the object allows a viewer on the other side of the object to perceive these light's waves. White light. When all the wavelengths between 400 to 700 nanometers are presented to the eye in nearly equal quantity, we get the sensation or perception of colorless or white light. White light is a mixture of all wavelengths of a visible spectrum occurring both naturally and artificially. Learn the source of white light and detailed spectrum of colors that it contains. White light is defined as the complete mixtures of all the wavelength of the visible spectrum. This means that if I have beam of light of all the colors of the rainbow and the focus of all the colors onto a single spot, all the combination of all the colors will result in a beam of white light. If we get 3 projectors with beams, the projecting eventually blue, green, red, and have the 3 beams overlap over the other. We will note the portion where the blue and green light merge over the green. It will produce the cyan color. The green and red lights a yellow color, and the red and blue lights a magenta color. Again, the additive color system involves light emitted directly from a source. Before object reflects the lights, the additive reproduction process makes various amounts of red, green, and blue lights to produce other colors. Combining of these additives primary colors with another produce the additive secondary color cyan, magenta, yellow. Combining all 3 primary colors produce white. Television and computer monitor create color using the primary colors of light. Each pixel on a monitor screen starts out as black. When the red, green, and blue phosphors of pixels are illuminated, simultaneously that pixels becomes white. This phenomenon is called additive color. Additive color rather. To illustrate additive color, imagine 3 spotlights, one red, one green, and one blue. Focus from the back of an ice arena on skaters in an ice show, where the blue and green spotlight overlap. The color cyan is produced where the blue and red spotlights overlap. The color magenta is produced where the red and green spotlight overlap. The color yellow is produced. When added together, red, green, and blue lights produce what we perceive as white light. To summarize, additive color involves the uses of colored lights. It starts with the darkness and mixes red, green, and blue lights together to produce other colors. When combined, the additive primary colors produce the appearance of white. Subtractive color mixtures. This time, the light beams of the 3 projectors will be covered each with cyan filter, yellow filter, and magenta filter, and the beams of light projected one over the others. Photographs, magazine, and other objects of nature such as an apple create color by subtracting or absorbing certain wavelength of color while reflecting other wavelength back to the viewer. This phenomenon is called subtractive color. A red apple is a good example of subtractive color. The apple really has no color. It has no light energy of its own. It merely reflects the wavelengths of white light that cause us to see red and absorb most of the other wavelength, which evokes the sensation of red. The viewer or detector can be the human eye. Film in a camera or a light sensing instrument. The subtractive color system involves the colorant and reflected lights. Subtractive colors start with an object, often as substrate such as a paper or canvas, that reflect lights and uses colorants such as pigments and dyes to subtract portion of the white light illuminating an object to produce other colors. If an object reflects all white light back to the viewer, it appears white. If an object absorbs or subtract all the light illuminating it, no light is reflecting back to the viewer and it appears black. It is the subtractive process that allows everyday objects around us to show color. To summarize, subtractive colors involves colorant and reflected lights. It uses cyan, magenta, and yellow pigments or dyes to subtract portion of white light, illuminating an object to produce other colors. When combined in equal amount, pure subtractive primary colors produce the appearance of black. Next, production of color. There are numbers of different in which color is produced. One need to know are variables quantities of color, or it possible to evaluate color as quantity. Number 1 is absorption. Number 2 is scattering. Number 3 is interference. Number 4 is fluorescence. And number 5 is dispersions. First, we have absorption. Absorption, the color of most ordinary objects are due to the fact that they do not absorb the same amount of light at each wavelength. Number 2 is scattering. The color of the blue sky is due to the scattering of the light by the atmosphere. Number 3, interference. Color can be also produced by interference of light. Waves in the thin film, like in a soap bubbles or a film of soils floating in the water. The light reflected from the top surface of such a film undergoes a reversal or phase, but the light reflected from the bottom surface does not undergo this type of change. Number 4, fluorescence. This happens when molecules of the fluorescent materials absorb energy at one wavelength and radiate it at another wavelength. And lastly, dispersion. Color may arise from differences in the refractive or binding power of transparent medium of light of different wavelength. The rainbow is a good example for this phenomenon. Bending of light. When traveling in open space, light travels in a straight line. However, when lights come in contact with an object, it may be bended in the following manner: reflection of light, transmission of light, and refraction. If contrary to the absorption of light, transmission and reflection of light occurred when the natural frequencies of the vibration of electron do not match the frequencies of the incidence of light. In such cases, when the light wave strikes the object, the electrons of the objects begin to vibrate. The electrons vibrate for a brief period of time, with a small amplitude, after which the energy is re-emitted as the light wave. If the object under consideration is transparent, the vibration of the electrons are passed on to neighboring atoms and are re-emitted from the opposite side of the object. In such cases, the light is said to be transmitted. If the object is opaque, the vibration of the electrons are not passed in bulk. Rather, the electrons of the atom vibrates for a short period of time and re-emitted as a reflected light wave from the surface of the object. When a ray light approaches a smooth polished surface and the light ray bounces back, it is called the reflection of light. The incident light ray which lands upon the surface is said to be reflected off the surface. The ray that bounces back is called the reflected ray. If a perpendicular were to be drawn on a reflecting surface, it would be called normal. Transmission of light, where light waves pass through a material without absorption, is affected by thickness and type of material. Refraction is a bending of wave when it passes from one medium to another. The bending is caused due to the differences in density between the two substances. And refraction of light is one of the most commonly observed phenomena, but other waves like sound waves and water waves also experience refraction. Refraction makes it possible for us to have optical instruments such as magnifying glasses, lenses, and prism. It is also because of the refraction of light that we are able to focus light on our retina. Kinds of the object as to how they behave to light. Transparent object, translucent object, and opaque objects. Transparent objects allow sufficient visible light to pass through them, that the object on the other side may be clearly seen.
Why?
Number 2. Translucent objects. Translucent objects allow lights to pass, however diffuse it sufficiently that objects on the other side may not be clearly distinguished. In some cases, the objects on the other side may be recognizable, but sharp detail and outline are obscured, while opaque objects so greatly diffuse the light that the recognizing the objects on the other side is very difficult, if not possible. So let's proceed to the source of light. There are two sources of light. The number one is natural light source and the artificial light source. Natural light source, the universal is filled with objects that emit light. Some light from these sources reaches the earth. The following things in nature have the ability to emit lights. The sun is the major source of the light for the earth. The sun is a massive ball of fire, at the center which nuclear fusion produces massive energy. This energy comes out as heat and light. The light from the sun is one of the major factors behind the sustainability of life on Earth. Every other star produces light too, but only a small or no amount of it reaches to the Earth because of the huge distance. The moon provides light as well, but it cannot produce light on its own. The light that we get from the moon is light reflected it from the sun. Some living organisms have the ability to produce light too. It is called bioluminescence. It is the effect of certain chemical reaction within the organism. Fireflies, jellyfish, glowworm, certain deep sea plants, and microorganisms can be cited as example. Certain other natural phenomena such as lightning and volcanic eruption also emit crimes. light rather. Artificial light source. Light source of this category are man-made, and it is divided into the continuous radiation and the short duration. So, continuous radiation are those that can give illumination continuously. And B, the short duration or the flash unit. A flash unit gives us a brief flash of light produced by a burning metallic wire or flash bulb or an electric discharge through a gas-filled tube or electronic flash. Excuse me. Artificial light source. Apart from natural source, light can be produced artificial too. The different light source produced artificially can be under three broad categories. Incandescent source. When certain objects are heated to a high temperature, they begin to emit light. But infrared and visible light is produced in the process. Example, candle and incandescent lamp. Next, luminescent source. Light can be produced by accelerating charges in luminescent materials. One common way of doing it by passing current through the materials. Example, fluorescent tube light and electric bulb. Next, and the last one, gas discharge source. Passing electricity through certain gases at very low pressure can be produced light too. Example for this is neon lamp and sodium lamp. Next, let's proceed to forensic light source. One is ultraviolet lamp. Two is laser or light amplification through simulated emission of radiation. 3. Alternative light source. And the last one is forensic light source. Ultraviolet lamp used in a forensic works come in variety of shape, sizes, and power. Some units are portable battery operated and are easily carried and can meet the rugged and rigorous demand for the field work. The ultraviolet radiation is broken down into the long wave ultraviolet, the medium wave ultraviolet, and the short wave ultraviolet. The long wave ultraviolet is used in a wide variety of applications in medical and forensic. Number 2, laser or light amplification through simulated emission of radiation. Laser stimulation of these items provide a way for the criminalists to finally see, locate, and visually record evidence that they know that they had been missing. The only drawback of laser is their cost. They are quite expensive. Laser is known as coherent light. Next, alternative light source, or let's us called ALS. The ALS use a variety of band pass filter to provide a high intensity beam of non-coherent light. These multiple band pass filters allow the operator to match the laser frequency available at crime scene. Additional wavelengths were included to allow the ALS to operate in the UV, near UV and IR spectrum. Let's proceed to the last one, which is forensic light source, or let's called FLS. The FLS is a term of being applied to a wide variety of relative inexpensive light source which is filtered white line. A band pass filters allow a fairly narrow band of light to pass through the object. This will enable criminals to search latent fingerprint of a surfaces. The white light source used with the FLS is as simple as maglite type handheld flashlight or spotlight with the filter in place. So that's the end of my discussion. I hope you learned something from me. Thank you for listening and God bless. Bye-bye.